Do you know how many cells just crossed your screen? Have you ever wondered how to make these awesome three-dimensional maps? Or do you want to know how many ice has actually melted since global warming has become such a hot topic? And all of this in a matter of minutes without using difficult calibrations but only a few clicks of your mouse? Look no further and welcome to Image Processing and Analysis in ImageJ. In order to do a proper accurate analysis, you need to process your data first. With ImageJ, we are able to display, annotate, edit, calibrate, measure, analyze, process, and save image data. What kind of processing is required depends on your question and image type. Lucky for you, ImageJ has a visual interface, so coding is not required. The ImageJ toolbar contains both built-in and customized tools for manipulating images. I'll introduce you to the most important ones. First of all, we have the area selection tools, out of which you can choose different shapes. The line selection tool is used to create line selections. The wand creates a selection by tracing objects of uniform color or thresholded objects. And the magnifying glass magnifies and reduces the view of the active image. On to the next step. Before you can start most analysis, you need to calibrate the image so the software knows what a pixel represents in real-world terms of size and distance. In other words, we need to set a scale. If your ant is 3 meters long, you know you did something wrong. Scale setting can be done in different ways. Some images have a scale bar, or for some objects you just know the distance, like for example a petri dish. Third option is to set the scale by directly entering the image resolution, which you might find in the info sheet of your image. But I think we've had enough theory. Let me show you a couple of examples. We'll start with counting objects. So over here I have a picture of Chlorella vulgaris and I want to count it. First we will calibrate the picture by setting the scale. This picture has a scale bar, so I'll start by zooming into it and tracing it with the line selection tool. Now I go to the Analyze toolbar. The traced length is shown here in pixel and I can now define this length as 10 micrometer. The scale bar has been set, so now I can start processing the picture. These steps will help create contrast so ImageJ can recognize different particles. I selected the area of interest using the area selection tool and now I duplicate the image. Next I subtract the background to minimize the noise. And you can play with the value of the rolling ball radius to get the desired effect. Next I will convert the picture to a black-white 8-bit type. This will help when setting a threshold. You can change the threshold manually until you feel the cells are accurately represented as black balls. Now I will make the image binary so that we can use the fill up holes function and so we can create perfect spheres. The reason we now convert the image to mask is so that we can use the watershed function. This will trace a 1-bit line between the individual cells. Now I go to Analyze and Analyze Particles. We set the minimum particle size and we get a picture of the traced cells and their output here. Now you know how to determine the amount of cells you saw earlier, right? Now I will show you how to measure a surface area. So here we have a Landsat image of an ice sheet. The processing of the picture is the same as that for the counting particles tutorial. You select the area, set the scale, convert to 8-bit and set a threshold. Just make sure to make the area you want to measure black. You now select the area you want to measure using the Wand selection tool. This will trace the area's outline. If you double-click on the elliptical selection tool, you can use the brush. This will trace the outline in detail. I first use a large brush size for the coarsework, and after that I do the details using a 10 pixel sized brush. Once you've finished tracing the outline of the area of interest, you may press Analyze and Measure. The output you can save as an Excel file. Now you can use this knowledge to compare temporal variation in surface area of, for instance, melting glaciers. The last thing I want to show you is how you can make three-dimensional images out of a calibrated mathematical map. So here we have an example of a calibrated depth map. You can make a 3D image out of it by clicking Analyze, Surface Plot, and then choose the items you like. You can try the different effects they have when you are processing your own image. When you prefer a more dynamic approach, you can make an interactive map by clicking Plugins, 3D, Interactive 3D Surface Plot. You can alter many parameters on this map, so it's best to play with it yourself. You can resize the grid, change the flatness, or the way you look at it. You can even show ISO lines instead of a full mesh. If you rather have an idea about the depth profile of a certain transect on a map, you can first draw the transect using the line selection tool. Clicking Analyze Plot Profile shows you the depth profile of a transect you've drawn earlier. If you'd like to see the actual data points, just click List to see them in ImageJ or Copy to export them to, for instance, Excel. That was pretty cool, huh? But unfortunately, this tutorial has come to an end. Please note that we only briefly touched the surface of ImageJ, and there's lots and lots of more amazing stuff to explore. Have fun!